Hello everyone. Welcome to Discoverix, the new channel where we will explore the most fascinating curiosities and wonders of the planet. Today, I have a thought-provoking question for you. Have you ever wondered how long a day would be if it were UN for the sun? Today, we are going to delve into the science behind this intriguing question and the incredible implications it would have. So first, we need to understand that Earth doesn't rotate in a vacuum. It's influenced by various external forces, primarily the sun and the moon. The most well-known influence that the sun and the moon have on Earth is the effect on ocean tides. Both exert gravitational forces that pull the ocean's water towards them, creating high and low tides. But what many people do not know is that this pulling action also exerts a drag force on the Earth, affecting its rotation. Deceleration effect, the drag created by ocean tides, acts like a gentle brake on Earth's rotation. This deceleration is minuscule, but over millions of years, it adds up. In fact, measurements show that the day is getting longer at a rate of about 1.7 milliseconds per century. This may seem irrelevant for human life, but it's a significant change on geological scales. Precession and nutation in addition to tides. The gravitational force exerted by the sun and the moon in phenomena known as precession and nutation. Precession is the slow, cyclic movement of Earth's axis of rotation, similar to what happens when you spin a top. Nutation is a smaller oscillation in this precession movement, primarily caused by the moon's gravitational influence. Both have effects on Earth's rotation, and by extension, the length of the day and night. Angular momentum transfer. Another interesting aspect is the transfer of angular momentum between Earth and the Moon. The Moon is accelerated and moves into a higher orbit around the Earth. This is a fascinating example of the conservation of angular momentum in a two-body system. Cumulative effects. All of these effects are cumulative and interconnected. They impact the Earth's rotation, the length of day and night, the seasons, and even the planet's long-term climate stability over millions of years. But what would happen if we eliminated these external influences? Well, according to scientific models, a day on Earth without external influences could last up to 65 hours. The idea of a 65-hour day on Earth is more of theoretical speculation than a well-grounded scientific theory. This notion is generally presented as a mental exercise to explore the mechanisms that govern Earth's rotation and how they might be different under certain extreme conditions. The 65 hours figure is generally not based on rigorous scientific calculations, but is more a way to illustrate how drastically the length of the day could change under specific circumstances. A key factor here is angular momentum, which is a measure of the amount of rotation an object has. The Earth has a certain angular momentum due to its rotation, and this momentum is conserved unless acted upon by an external force. Currently, various external forces, like the gravitational pull of the sun and moon, influence Earth's angular momentum, and, therefore, the length of the day. The speculation is that if we could magically eliminate all the external influences affecting Earth's rotation, the Earth could assume a rotation that would make a day last much longer. The idea of 65 hours is generally presented as a way to capture people's imagination about how different our world could be. In this hypothetical scenario, several factors would have to be considered. For example, how would angular momentum be redistributed? How would centripetal forces affect the shape of the Earth and, by extension, climate patterns? How would this affect the gravitational patterns that govern Earth's orbit around the Sun? While the idea of a 65-hour day is largely speculative, it serves to illustrate the importance of external forces acting upon the Earth. It also allows us to reflect on how seemingly immutable aspects of our world, like the length of the day, are actually products of a series of complex and interconnected factors. It's important to note that this idea faces many scientific and logical challenges. The Earth is in a solar system with many other bodies, and the removal of any of these factors would have cascading implications that are difficult to predict. So, just imagine 3 days and 3 nights in a single day. What would this mean for us? Think about the implications for life as we know it. Practical implications. Sleep patterns. The human circadian rhythm, which is adapted to a day of approximately 24 hours, would be severely affected. This would have significant health implications, including potential problems with sleep, mood, and even metabolic functions. Work schedules. With a longer day, the concept of 9 to 5 feet would become obsolete. Businesses and schools would have to completely rethink work and teaching schedules. Agriculture. The extended light and darkness patterns would affect plant growth and harvest cycles, perhaps requiring the development of new agricultural practices or varieties of plants. Animal life. Animals, many of which have circadian rhythms adapted to current conditions, would face challenges in adapting. This could affect ecosystems in unpredictable ways. Energy and infrastructure. There would be extended periods of darkness and light, requiring changes in energy generation and storage strategies. Theoretical implications. Climate and meteorology. A longer day would likely lead to climatic extremes, with higher temperatures during the extended day and lower temperatures during the extended night. This could require entirely new climate models. Astronomy and navigation. Stars and other celestial bodies would appear in different positions in the sky during the day, affecting everything from amateur astronomy to complex navigation systems. Plate tectonics. The redistribution of angular momentum could, theoretically, have some effect on tectonic stresses. Although this is a topic of great speculation, evolution of life, with new selective pressures at play, we might see an acceleration in the evolution of new species adapted to these extreme conditions. Social and cultural systems. Concepts like weeks, months, and even years might need revision. Festivals and celebrations based on daily or seasonal cycles would also need to be adjusted. Global economy. Global trade and financial markets, already complex in a 24-hour world, would face new challenges and opportunities. The length of Earth's day has a profound impact on climate and meteorology. So a 65-hour day would bring about drastic climate changes. Extreme temperatures, extended warming. A prolonged period of sunlight would lead to much higher temperatures than we are used to. This would increase the rate of evaporation, potentially leading to more frequent and intense droughts. Extended cooling. Similarly, a prolonged period of darkness would result in much lower nighttime temperatures. Areas that currently experience overnight frost could face far more extreme freezes. Atmospheric circulation patterns would be affected, possibly leading to changes in jet streams, which in turn could alter global weather and climate patterns. Longer periods of warming and cooling would affect cloud formation and precipitation patterns, potentially causing more extreme weather events like storms or droughts, while the effect on tides would be more complex and dependent on many factors. It's possible that changes in Earth's rotation would affect ocean currents, which in turn would have a significant impact on climate. Sunlight plays an important role in the biogeochemical cycles of the oceans, including the photosynthesis of phytoplankton. A longer day could affect these processes and, by extension, the entire marine food chain. Changes in climate and weather patterns would have a cascading impact on ecosystems, affecting everything from natural habitats to animal and plant populations. Animals that migrate based on light and temperature cycles could face significant challenges, potentially leading to extinctions or rapid evolutions. As mentioned earlier, agriculture would be one of the most impacted sectors, with possible ramifications on food security. More frequent and intense climate extremes could lead to a range of public health issues, from heat waves to flooding. In summary, a 65-hour day would have far-reaching climate implications that would affect almost every aspect of life. Climate science would have to be practically rewritten to accommodate this new reality. Well, we've covered a lot today, haven't we? From gravitational phenomena to life on a planet with 65-hour days. Science really gets us thinking about what could have been. So, I want to hear from you. How do you think a 65-hour day would affect our society and our world? Leave your thoughts in the comments below. If you enjoyed this video, please give it a like and subscribe to the channel to discover more curiosities and oddities. Thank you for sticking around. See you in the next video.